In this video, we're going to take a look at a concept in object-oriented programming called inheritance. I'm going to start this off assuming that you have a sense of object-oriented programming on just a very basic level. You need to know what classes and objects are and how they relate to one another. Yeah, you're going to need some basic vocabulary that we use when talking about classes and objects. So if you're not quite to that point yet, maybe go check out some other resources and then come back here when you're ready to take a look at inheritance. The other thing up front is that this video is going to talk about inheritance as an idea and as a feature of object-oriented programming. We're not going to get into writing code in this video because that's going to depend on the programming language that you're using, and you'll move on to that soon enough. When we talk about object-oriented programming, we talk about the 4 pillars of OOP. Inheritance is one of those, along with abstraction, encapsulation, and polymorphism. We're not going to get into those other 3 in this video. And as I like to do, we'll start with just the very basic question: what is inheritance? So in our life outside of programming, inheritance is a term that refers to things that you get from your parents. So maybe you inherit a big pile of money or a big house. But that kind of stuff really depends on the circumstances, obviously. There are some things that you inherit no matter what. For example, you might inherit your parents' hair color. Somebody says, "Hey, where'd you get that great hair?" "Oh, I inherited it from my parent." In that case, you've inherited a characteristic or an attribute. You might also notice that you have some kind of habit, some mannerism from your parents. Maybe you tap your fingers in a certain way and you notice that your mom or dad does that. In that case, you've kind of inherited a behavior. In programming, as a kind of a technical definition of inheritance, we're going to say that inheritance is the ability to base a class on a different class. And it turns out that just like in real life, in our programming, in OOP, our class or our objects can inherit attributes and behaviors too. Let's take an example of a bank account. So there are going to be some attributes and behaviors that will be common to all bank accounts. They're going to have an account number, an owner name, and a balance that we need to keep track of. We're going to have the ability to make deposits and withdrawals, and we're going to need to be able to get the balance. And obviously all kinds of other stuff too, but for a simplified version of it. But it turns out that there are different kinds of bank accounts. You might have a checking account and a savings account, for example. You can see that all 3 of these classes, all 3 of these things have a lot in common. Inheritance allows us to say that a checking account is a type of bank account. So it can inherit the behaviors and attributes that any bank account has. And since a savings account is also a type of bank account, it can inherit those same things. Now, a key benefit here to using inheritance is that anything that's inherited by a class doesn't have to be re-implemented. In other words, you don't have to write code for those things. You've already written the code in the bank account class. Instead, we can just add the attributes and behaviors that are specific to those kinds of accounts. Now, a checking account has all the attributes and behaviors of a bank account, plus those things that are specific to a checking account only, like the last check number that was written, the ability to write a check, and the ability to reorder checks. Similarly, a savings account is going to inherit all of those attributes and behaviors that are already in a bank account, and then we can add on the interest rate and then a method to calculate and add interest into the balance. Now, we're going to need some vocabulary to be able to talk about these relationships, right? This hierarchy of relationships that we are establishing. So at the very top of this, the class that everything is going to be inheriting from, we can refer to that as the parent class. And any class that inherits from that, we can refer to that as a child class. Now, when we talk about implementing these in our code, we also are going to start using some other terms. So C# coders might refer to these as a base class and a derived class. And in Java, we might call them a superclass and a subclass. And those last two are the ones that I tend to use a lot. When we're talking about the design phase, which is what we're doing in this video, it's probably more correct to use the terms parent and child. But honestly, I use them all pretty interchangeably, and as far as I can tell, so does everybody else. The next step in describing this is when we say that one class inherits from another, the word we use is extends. So we say that a checking account extends bank account. And that makes sense because a checking account takes what the bank account has and can do, and it adds on to it, or it goes beyond a bank account. It essentially extends the functionality of a bank account. Same thing for a savings account, which is going to extend the functionality of the bank account as well. One thing we can do to sort of self-check and make sure that we are thinking about our inheritance correctly when we're doing our design is what we call the is-a test. And the idea here is that inheritance is used when one class is a specific type of another class. So we could say a checking account is a bank account. That makes sense. So a checking account extends bank account. We wouldn't say that a savings account is a checking account, right? A savings account, you can't write checks and do all that kind of stuff. So it wouldn't be appropriate to set up with savings account extending checking account. A savings account is a type of bank account, so it's going to extend the bank account class just like checking account does. And we can go beyond that. I didn't show it here, but we can have a VIP savings account, which maybe has some other features and a higher interest rate or something like that. That could extend savings account, which extends bank account. And so we can have multiple levels of this. And in fact, it turns out that there are some other kind of variations or other ways to look at inheritance relationships, especially when we get into the idea of polymorphism, which is another one of those pillars of object-oriented programming that I started with. That's really beyond the scope of what we're doing here, but just understand that this is the simplest example of inheritance, and there can be other things that we can do with it. But for now, I think this gives us enough of an understanding of what inheritance is to go off now and see how to implement that in our own programming language. That's the next step for you, but for now, if you have any questions, be sure and reach out.